So in this last video, I just wanted to show you a way to uh, guess what that line is that's running through your data and do it in a sort of a more automatic way, I guess we should say. We're going to have R use a function called LM to find the least squared regression line for the data set that you're giving it. And we'll go through what that means later in class, but we'll just see how it'll give us this line without us having to sort of just guess and check and guess and check. So we'll start with another data set. This is going to be my example 6 data set. I'll plot these points. Looks something like that. And then I'm going to throw, well, I don't even want to throw a line on there yet. So the way I can go about sort of guessing where this line is that runs through these, which I should think, yes, it does look like it's a straight line and something like this is running through it, is I can make up a variable I'll call fit, and then I'll use the LM function. And then the nice thing here is I just have to tell it I want to do a linear function of y based upon x. So I want to use a formula here. And my y actually shouldn't be y. My y, hey Siri, you should go away now. My y should actually be ex6, that data right there. And then what I have to do is just tell it where my data lives. And my data lives in that data frame called lab 12. And so I can run that. And if I run the summary command, what I will see, oops, I gotta put the whole summary command in there, summary command of fit. I'll see a bunch of information on there, but basically what I'm interested in is this is the intercept down here, and this is the slope of a line that looks like it fits through that data. Lots of things will fit through there. But this is sort of one special kind of thing called the least squares fit. And so we'll try using this guy. And so the way I can go about plotting that red line through there is I can use my AB line function. And if I look at that, I can say to myself, well, I need to have those coefficients, which I got to learn to spell. So I will copy and paste that instead of trying to do anything else. I'll use the coefficients function to pull the coefficients out of these results right here. So I'll do coefficients of fit, and that'll actually use my slope and intercept that are showing up down here, and then I'll make them red. So color equals red, just so we can see it. And we can see we have a line running through there. And then the next thing we want to check to see if this actually works out nicely for us, at least the way we're going to want it to in the long run, is we're going to want to make a couple of plots. And the plots I want to make are going to be the plots that look at the difference between the shifted values in this line here and just looking at those residuals, which is what they're called, seeing if those look kind of normal to us. So I'm going to make a histogram of those things called residuals, and they're going to be collected inside that guy fit. So I'll use this command here, and if I plot this, I do indeed get something that's centered at 0 and looks kind of normal. And notice it's not a standard normal. There's much more of a spread to this because I'm going down to negative 100 up to positive 100 at the very least. But it does look normal and centered at 0. And so then the next thing I'd want to look at is just a plot of my fitted values, okay, which are going to be the lines that are sitting on, or the points that are sitting on this line. I'm going to ask what's the difference between those and these residuals here. Or not what's the difference, but what's the picture look like when I plot them together like we did before. And when I do that, I'm going to throw on my AB line of horizontal equals 0. I'll make color equal red again. And you'll notice you still get the same kind of pattern where they're sort of evenly spread one side to the other. You don't really see a pattern to them. In other cases, you might see something that doesn't look like this. And so that's what we have to be aware of. Okay, so that's how you can use that LM function to sort of get a guess for the line running through that. And then you can also go ahead and check what the histogram looks like for those residuals, for those shifting amounts. What we want them to look like is normal, and then what we want them also to look like when we make a scatter plot comparing them or associating them with our fitted values, the values on that regression line. We want something that's basically, again, centered at 0, and we want to see really no pattern there. Okay, so that's it.